Hey guys, in this short video we're going to look at how we can find uh, angles using trigonometry. And so we're going to go through 4 examples together, and then you're going to try 3 or 4 on your own. So we're going to take a look at this first problem, and the challenge that we have here is we know that we could find the missing side if we want to using the Pythagorean theorem. So if we wanted to find that. However, we don't want to do that in this problem. Rather than that, we want to try to figure out what this missing angle is going to be. And what we're going to use is we're going to use our trigonometry ratios that we learned in the previous lesson to help us do that. So just as a brief reminder, the 3 ratios are going to be our sine ratio, our cosine ratio, and our tangent ratio. And a good way that I told you in the last video to remember it is this acronym SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we're going to use this in all 4 of our examples in this video. So looking at this first example, in order to find this angle right here, this theta angle, what I need to do is I need to identify what the 5 and the 12 are in relationship to that. Well, since the 5 is across or not touching the angle, we're going to go ahead and call that my opposite side. The longest side is always the hypotenuse, so that's going to be the one here that's not even marked. And the 12 then, by default, has to be considered my adjacent side. So in terms of deciding what ratio here best represent the 5 and the 12, the answer to that is going to be the one that uses opposite and adjacent. In this case, that means tangent. So what we're going to say then is that the tangent ratio of the angle theta, so tangent of angle theta is equal to the opposite side of theta, which is 5, over the adjacent side, which is 12. And this is where we're going to have to now turn and use our calculators to help us finish this problem off. And for the purposes of this video, I'm going to be using the Desmos calculator, since you all can access that either online or on your phone. So in order to do this, what we have to essentially do is get this theta to be by itself. And what I'm going to do is I'm going to use an operation just like we've used for addition. The inverse of that is subtraction. The inverse of multiplication is division. And so in this case, we need to do whatever the inverse of tangent is. And there's no fancy name for it. The name for it is going to be called inverse tangent. Inverse tangent. And basically the background of this is, in a calculator, if you type in tangent of 35, so that's an angle. If you type in tangent of an angle, when you press enter in your calculator, the answer that it gives you is its ratio. So when you know the angle, you do tangent 35 and it tells you the ratio. Well, inverse tangent, which is denoted in our calculator with a little -1 next to the TAN, when I put in my ratio instead, so in this case the ratio is, 5 over 12, okay? When I put that 5 over 12 in, I'm telling the calculator my ratio. When I press enter, what the calculator then is going to give me instead is it's going to give me my angle. So you can see that it's a reverse. Regular tangent, you give the angle, calculator tells you the ratio. But in the inverse, you're going to give the calculator the ratio, and it's going to give you the angle. So we're going to use this tangent -1 feature now in Desmos. And the ratio is 5 over 12. So let's go over to Desmos now and take a look at how we do that. So we're going to press start graphing. And the one thing we have to ensure here is there's actually 2 ways to measure angles in math. The way that you're familiar with is called degrees, and the way that you'll learn in future classes is called radians. By default, Desmos uses radians, so we need to switch it. So you press this little gear icon in the top right-hand corner, and we're going to go ahead and select degrees. And so now anything I type in here is going to be in degrees. So what I have to tell the calculator now that I want to do is I want to do, as my problem states here, I want to take the tangent inverse of 5/12. So I'm going to rewrite this statement down here as tangent inverse of 5/12. And so I need to put that in my calculator. The way you're going to locate that is in the bottom left-hand corner, there's a keyboard that comes up in Desmos. And you're going to click on the word functions. And when you see that, you'll see our regular sine, cosine, and tangent that you're familiar with from the last lesson. But next to it, you'll see sine -1, cosine -1, tangent -1. And those mean inverse. That's what the -1 means. So I'm going to click the tangent -1 button, and then the parentheses will open. I'm going to type in 5 divided by, and I already forgot the other number. I think it's 12. Yes, it's 12. So 5 divided, I got to click inside that gray box. We're going to put in 12, and just like that, you'll see that the calculator immediately computes what the angle is going to be. So it's saying that when the tangent ratio is 5 over 12, the angle must be 22.6. And that's going to be the answer that I'm going to write here. So my final answer for this question is theta equals 22.6. That's all there is to it. It sounds a little tricky, but remember that your calculator, you're just telling it that I know the ratio, and calculator, I want you to tell me what the angle is going to be. And that's what the inverse feature of this does for us. So we're going to go through the next few examples a little quicker, but we're going to use the same process. So looking at the second example, in this case, we are looking to find a ratio that uses 36 and 39. Well, here's our theta right here. That's what we're trying to find. 36 is going to be considered my opposite side, and 39 is going to be considered my hypotenuse side. So which ratio is opposite and hypotenuse? If I go back up to my chart here of sine, cosine, and tangent, it looks like this one's going to be sine. So it's going to be sine of theta equals 36 over 39. And so in order to find the angle, what I'm going to have to type in my calculator is we're going to use the sine inverse feature, or sine -1. And we're going to type in the ratio 36 over 39. And that's what's going to give me my angle. So let's go ahead over back to Desmos and knock that out. So sine inverse of 36 39. So let's do that. So we're going to hit the functions key. We're going to type in sine -1, 36 divided by 39. And immediately, oops, that was a typo, 36 over 39, there it is. 67.4 looks to be my answer. So that's going to be my final answer. 67.4 degrees. We'll go ahead and circle that, and we'll call that our final answer. So tricky in terms of the setup, but the actual evaluation is really simple using our calculators. So pause for a moment, and I want you to decide what ratios should we use for this problem. Here's my angle, and the two numbers that I know are 18 and 24. 18 is the opposite. 24 is the hypotenuse. So which one is opposite and hypotenuse? So that's going to be the sine ratio again. So it's going to be sine of theta equals 18 over 24, which means in my calculator, I'm going to type in sine -1 of 18 over 24. And when I press enter, it's going to give me what the angle is. So let's go ahead and do that. So we're going to go ahead back to functions, sine -1, and we're going to type in 18 divided by 24. And just like that, I get 48, and I'm going to round it to the nearest tenth, 48.6 degrees. And there is our final answer. So let's look at one final question for this video, and then I'm going to give you a few to try on your own as a wrap-up, and I'll have an answer key for you to check. So for this last problem, you'll see there's a square root in the problem. It doesn't actually change what we do. I just wanted to address it with you to show you what we need to do with this. So here's my angle. The 1 and the square root of 2 are the two sides I need to find the ratio of. Well, by definition, the square root of 2 is considered my hypotenuse, and the 1 is considered my adjacent, since it's the leg that it's next to. Adjacent and hypotenuse is going to be our cosine ratio using SOHCAHTOA. So cosine of theta is equal to 1 over the square root of 2. Now, I know some of you might look at that and go, well, I have to simplify that. Well, we're not done the question. We're actually going to go ahead and we need to do that cosine inverse, and we're going to do 1 over the square root of 2. And by typing that in my calculator, it's going to go right ahead and compute the angle for me. Now, some of you might recognize those two numbers from a previous lesson. And if you do, the answer here we're about to get may not surprise you. So let's go ahead and see what happens. So we're going to go functions. We're going to go cosine -1. And we're going to do 1 divided by, and then the square root button is down. You can't see it on my screen, but it's at the very bottom, 2. And you'll see that the answer that I got here is 45. 45. If that didn't come as a surprise to you, then you might recall that this is a special right triangle, and that's where that number comes from. So here are the 4 examples in quick summary. What I want you to do as we wrap up this video is to scroll down here, and you'll see that there are 6 examples. I'm going to have you ask that you pause the video at this time, try these ones out, and then when you're ready, press play, and I will have a full solution set ready for you. Okay, and here are the answers you've been waiting for those final 6 questions. You'll see in each of these questions I rounded it to the nearest tenth of a degree. I know I kind of went against the rules at the top here. This is rounded to the nearest degree. Honestly, it's not a big deal to me. I always like, as a safety precaution, go round to the nearest tenth of a degree. But if the directions say nearest degree, you obviously can round these, which would change this to 38, 37, 22 down here in the bottom right, 54, and lastly 45 there. So that will conclude this video. Please take a look at some of the additional practice problems that you can do as well, and please reach out if you have any questions.